these are all going to set up some kind of rational equation. So we're going to have fractions in our equation again today, but we're just going to have to pick out the information to set this up. All right, so let's go read this to you real quick. So it says, Amy and Sarah volunteered to contact every member of their club by text to inform them of an upcoming event. Now, I'm going to have a couple pieces of information here. All right, so it says Sarah can do all the text messages in 8 hours if she works by herself. Okay, then it says Amy can complete, so we got another girl, Amy, she can do all the text messages in 12 hours if she works by herself. Okay, how long will it take them to complete sending the text messages if they work together? Okay, now, the deal with this, and if you look at a different book or something like that, it'll probably tell you a different way to do it than I'm going to show you, because I think my way is way easier. Okay, so it doesn't tell us how many text messages we have to send, right? It doesn't say, hey, we're sending 500 text messages, whatever. So what I do is and you can use a variable, but I just use the number 1. I'm going to let 1 represent all the text messages that they have to send. I'm just going to let 1. I'm going to do that in almost every single one of these questions today, unless they give me a specific amount. I'm going to let 1 stand for whatever the action is that we're doing here. We're sending text messages. Okay, so for the first girl, her name is Sarah. Her rate, like how fast she would do the text messages, her rate would be the number of text messages, which we don't know, we're just going to let 1 represent that, divided by the amount of time it would take her, which it tells you is 8 hours. So literally just 1/8. Okay, now the other girl, her name's Amy. It says she can do all the text messages, so the same thing. I'm just letting 1 represent all the text messages. Her rate would be, I'm going to complete all of these, and her time is 12 hours. Okay, now, if they work together, so I'm just going to come over here. So again, they're going to do the same amount of text messages, but they're going to work together. How long is it going to take them? In that case, working together, I don't know their time. Okay, if they're working together, what would you do with the rates? Like if they're helping each other, like would I multiply, divide, add, subtract? You're going to add. Okay, so that's literally all we're going to do, right? That's it. Okay, tell me a common denominator between 8, 12, and x. 24, I think, is the smallest number both of those will go into, and they both need an x. Okay, so I'm going to make 24x my denominator. All right, to do that, this first guy, we would need 3 in x. Second guy, we'd need 2 in x. I have an x here, but I don't have any numbers at all, so I would need the 24. Okay, if I can make all my denominators match, we're just going to cross all these guys out. And so then I would, and not all these questions are nice answers, so we would have 3x plus 2x equals 24. So I'm going to add these guys up. This will give me 5x equals 24. And that's not a horrible decimal, but I'm just going to divide 24 by 5. So we're going to get 4.8. Now, it told both girls times in hours, so your answer will be in the same unit. So this will be 4.8 hours. And that's it. Does anybody have any questions? Okay, the worst part is setting it up. Okay, now this says Eli can paint a room in 3 hours. So I'm going to do the same thing. It's not going to tell you like the room has 3 walls that need to be painted. It doesn't say anything like that. It just says he can paint a room in 3 hours. So I'm going to let 1 represent just painting the room. You could literally use anything that you want. You could use a letter. You could use a number. I just use 1 because it's the smallest thing I can think of that would be easy. So for Eli, paints the 1 room in 3 hours. That would be his rate. Okay, his sister, Faith, helps, but it says it takes them 2 hours and 24 minutes. So if they're working together here, so I actually have a little bit different information than the previous question. So for her, we don't know her time by herself. But together, now this is kind of tricky. So his time is 3 hours. That's a nice number, right? Their time together is 2 hours and 24 minutes. How could you figure out what that would be in hours? Like 2 hours and 24 minutes. How could I write that in hours? What do you think?
Convert it on the minutes and divide it by 60.
Okay, how would you convert it in the minutes?
Well, 60 times 2 is 120.
Right.
24.
Okay, so you're going to do the whole thing. Okay, so he's saying 120 would be 2 hours, right? Plus 24, so we'd have 144, and then you want to divide that by 60? Because there's 60 minutes in an hour. We're just going to convert this real quick. So 144 divided by 60, sorry, that's really light colored today. We'll change that up, 2.4. All right, so together, 2.4 hours. Now, this is a little annoying to work with if you have a decimal to create a common denominator there, right? So I'm just going to do one tiny step to make this a little bit easier for you. So let me rewrite this. I'm going to keep this 1/3, and I'm going to keep this 1 over x. All I'm going to do here, just to get rid of the decimal, does anybody know how to get rid of the decimal, like what you would do? Like, how do I scooch a decimal place over? Multiply by 10. That's all I'm going to do. I'm going to do top and bottom by 10 here. Okay, this will make it easier to get a common denominator. So this would be 10 over 24. If I multiply that by 10, it just scooches that decimal place one spot over, but it's going to change the top to be 10. But this will be so much easier to get a common denominator. What would you use the common denominator for here? Or what would you use as your common denominator here? Actually the same thing. I didn't do that on purpose, but the same thing as the last question. So top and bottom here by x, top and bottom here by 24, and then 3 times 8 is going to give you 24, so this top and bottom here by 8x. All right, all my denominators match up, so I'm going to cross that out. I'm going to have, to solve this equation, 8x plus 24 equals 10x. And then these equations, like I said, once you set it up, they're usually not nearly as difficult as the last couple of days that what we've been working on. So I'm going to subtract 8x from both sides there. You get 24 equals 2x. So what would her time be? What's 24 divided by 2? Okay, I was about to have a heart attack. All right. So her time, now since his time was in hours, together their answer was in hours and minutes, but we converted that into hours. This answer would be in hours as well. Okay, does anybody have a question? All right. Now this one's a little bit weird. Okay, so this says if the faucet is running, a bathtub can be filled in 10 minutes. Then it says it takes 14 minutes to drain the same bathtub if it's full. Okay, it says if the faucet is running and the drain is open at the same time, could the bathtub be filled up? Okay, so if it takes you 10 minutes to fill the bathtub but 14 minutes to drain it, if both of those things were going at the same time, could you fill it up? Yeah, the drain's slower, right? The drain's slower, so this could fill up. Okay, so here's how this works. Again, they don't give me like, here's the volume of the tub or anything like that. Okay, I'm gonna let 1 represent like filling up the tub. You don't have to write that all out. Okay, but the faucet being on, to fill up 1 tub, it says it takes 10 minutes. Now, the drain, to drain that 1 tub, would take 14 minutes. So this is for the first one is for the faucet, and this is for the drain. And we want to see if we can fill the tub up, if this is possible. What would you put between the 1/10 and the 1/14 there? If I'm pouring water in with the faucet, but I'm draining water, having the drain open, would you add those together? because the drain is working against you, right? So you're gonna subtract here. That's all that is. So if the faucet's open, we're putting water in, but the drain is pulling it out, it's actually a subtraction problem in this question. Can anybody think of a number that 10 and 14 both go into? I could use 140, but I think they both go, I know 10 does. Let me see if 14 goes into 70. Hold on. I think it does. It does. It's fine. Okay. Let's use 70 then. All right. You need an X. So I'm going to do top and bottom by 7X and top and bottom here by 5. Sorry, I started right at 2. 5X. And then I have the X, so I'm going to use 70. 14 and 10 both go into 70. All right, once you match those up, we're just going to cross that denominator out. Don't even worry about it. And we're going to solve 7x minus 5x equals 70. All right, so this would be 2x equals 70. So if we had the faucet and the drain going at the same time, we could still fill the bathtub up, but it would take, this is going to be in minutes because both of those were in minutes. 70 divided by 2 is 35, so it would take 35 minutes. Does anybody have a question? Okay. Now, these guys are just a little bit different. Now, this gives you the time for these two girls working together. So it says, working together, Jenny and Mackenzie can landscape a yard in 3 hours. So if these two girls work together, 3 hours. So I'm just going to do 1/3. One's going to represent landscaping the yard. Okay, they're going to work together, so I'm going to add these two fractions together. Okay, if Jenny works by herself, it takes her 8 hours longer than Mackenzie to landscape the yard. Okay, so I don't know the time for either one. All right, so let's say Mackenzie, I just called her time X. The other girl, it says it takes her 8 hours longer. So same, we're going to landscape the same exact yard, so keep that one. How would you represent it takes her 8 hours longer? Plus 8, yep. You just do just x plus 8. 8 hours, if it takes her 2 hours, it's going to take her 10 hours. That's all it is. Okay, now this one's a little bit harder. So what I want to do here, my common denominator, you can't just add an 8 into this, right? So this is going to need a 3 and it's going to need an x because I've got a 3 in this one. Okay, cannot just add 8 into this. So I need a 3 and I also need the x plus 8. And then on this one, I have the 3, but I need the x and the x plus 8 to create a common denominator. So this one is going to probably be the trickiest of all the ones that we've done so far. All right, so all my denominators match. I'm just going to cross this out. And I'm going to do this as I go. So this first fraction, we're going to get a quadratic because we're going to have x times x plus 8. So x times x, I'm going to write it over here, give you x squared. X times 8 would be plus 8x. On the other side, this is just 3 times 1, so that's going to stay 3, but I'm going to have to distribute that to that x plus 8. So we're going to get 3x plus 24. And then on the end here, you just have 1 times 3x, so just another 3x. So if you want, I'm going to do one little step here. This guy would be 6x plus 24. I do have a quadratic, though. I can't cancel the x squared out, so I want to set this equal to 0. Easiest thing I can tell you to do, keep your x squared term positive. So for this question, I'm going to move the 6x and the 24. Got to subtract those both to the other side. And when I do that, I can combine the negative 6x with the 8x. So this can be 2x, and then there's nothing to combine that negative 24 with. All right, can you guys think of two numbers you'd multiply to get negative 24, but they'd add to get positive 2? 6 and negative 4. Okay, what are my actual answers to that equation? Negative 6 and 4. Which one do you not think I'm going to use in my answer? Why? Time can't be negative. So just 4 would be the answer here. Now, which person? So it says, let's see, Jenny works alone. It takes her 8 hours longer. Okay, so this is going to be for Mackenzie. And then Jenny is going to be 8 hours longer. So I would literally just add 8 to that. 12 would be Jenny's time. And you can plug those back into the original problem. I promise that'll make that work. But when you find X there, you're finding Mackenzie's time, and then 8 hours longer would be Jenny's. So I literally just added 8 to that to get the other girl's time. Does anybody have a question? Okay. Here's what we're gonna do. I'm gonna do one more, and then we'll save the other 2 for finish up tomorrow. Okay. Now this one's a little weird as well. This says Grady takes twice as long as Lydia to complete a project. Together, they can complete the project in 10 hours. How long will it take each of them to complete the project alone? So they don't give you the time for either person. And I'm gonna let one just represent the project. Okay. It says Grady takes twice as long as Lydia. So to do the one project, let's say she took X, what is this in? It's in 10 hours. So let's say it takes X hours. This will be for Lydia. Okay, now they're going to work together and it's going to take 10 hours. Right? Now, they don't tell you the time for either person and it tells you it takes Grady twice as long as her to complete the project. What would you put on the bottom of his fraction if he takes twice as long? 2x. Okay, what do you want to use as the common denominator here? We could do 10x for sure. Okay, top and bottom, this would need an x. This would need a 5. And this one would need a 10. All right, so 10x is the denominator in each one of those fractions. Cross it on out. And this is actually really nice because this is literally just on the top of this, you just have 10, you have 5, and then you have x. So just literally 10 plus 5. Now, this is x. All right, so in this particular situation, that is going to represent Lydia's time, which would be 15 hours. And then Grady takes twice as long. So I could like plug it in there or just multiply 15 by 2. If he was working by himself, it would take him 30 hours to complete the project. Okay.